And good afternoon. 8 years ago, actually it's almost 10 years ago now, an event happened to me that changed the course of my life that she was talking about. And I'm going to just talk about that briefly because I don't think I'd be standing here today had that not happened. And I was in that emergency room. It was 4 o'clock that morning. I had an excruciating flank pain, but I'd had an 8-year history of it. And my primary care physician told me you just need to drink more water. I'll tell you what it is here in just a second. I had to go to a urologist, and he told me, yeah, you're doing the right thing, avoid oxalate foods. But a hospitalist came in, and he had taken this CT scan, and there was this little guy right here. And everybody probably don't have to be a urologist to know that's a kidney stone. But I was going to remind you that I had an 8-year history of that. I was passing them at my office. And everybody told me you're dehydrated. I've only been here a year. I come from South Texas, real South Texas in McAllen. It's even hotter there this summer than it was here. But, so I understand that maybe my urine was concentrated, he was saying, and just avoid oxalates because I had a calcium oxalate. There's many different types of kidney stones, but that's the more common one. And so I fit right into the plan, but I just kept having this over and over and over again. And this hospitalist took enough time to sit with me. He was a visiting hospitalist. He said, the bad news is you got them on both sides of your kidneys and they're full. So you got a whole family of kidney stones that are fixing to give you trouble. And then I forgot to say that back home in McAllen, the guys down there, us Hispanics, tend to do what's called an abrazo when they see you. They grab you and they hug you and they slap you on the back. And there's 2 or 3 of those guys I would avoid because even if I passed my kidney stone, I always had chronic low-grade flank pain. And they were just constantly there. So let's just do a quick anatomy. Here's kidneys, and there are these tubes that go down. And here's 2 stones in these tubes. Now, and here under magnification, and I actually looked at mine. I got pretty interested in this over the years, and I actually looked at mine, and they look like that. There's nothing smooth to them. They're not built. The design of those kidneys in those tubes are not to transport that kidney stone out of your body. So what is it doing there? What is it doing there? And he finally told me what he was doing there. Nobody else. None of my all healthcare professionals had flunked the exam with me. They didn't look through the weeds to find out like he did. He said, well, first of all, I was at that time, if you look at my BMI, I was in the overweight category. And not to get into all the different things, I was either pre this or already that. And my physician who was related to me, he said, well, we can manage it. You'll be all right. He was my buddy. Don't worry about it. But I was really in serious trouble. And there's a lot of heart disease in my family. And that little physician, hospitalist came in and he said, your urine. And I said, it's not yellow? I mean, what's wrong with my urine? He says, it's acidic. It's 5.0. And I said, well, what is it supposed to be? He said, their whole body is supposed to be neutral. It's supposed to be 7. He says, I think that's your problem. I think that you have an acidic environment in your body. And it is the proper environment for the body to try to neutralize that by producing more calcium. And anything in the area, it's going to calcify. He said, I think that might be your problem. It just didn't make sense to me. He said all animal proteins are metabolized acidically in the body. All fruits and vegetables are the counter. They are metabolized as an alkaline. And a light went off in my head. But I just couldn't believe it was that simple. Because I know lots of guys that ate like I did. And I know I was basically your carnivore there. I was unfortunately big into the SAD diet. But so were a lot of my friends. And they weren't experiencing what I was experiencing. Just I wasn't convinced. So I went over and started looking in through the literature. And right 2013, right off the bat, right that same year, I found this. And this is for people, the nutrition for kidney stone disease is that these idiopathic oxalate stone formers are advised to reduce ingestion of animal protein. Right there is the article to eliminate, minimize oxalate foods and sodium. The problem is oxalate foods are everywhere. Everybody, we're going to have some for lunch. I promise you, oxalates are everywhere. And I started looking at, I wasn't really having that many of them. The only thing I was really having that was a lot of oxalate was black tea that has oxalate, but it has very, very little. It's like saying banana has got a lot of potassium. It's got some, but there's so many more foods that have much more. And there is a lot of foods that have a lot more oxalates. So anyway, they recommend that. So I went to the National Kidney Foundation, and they advise for people that are undergoing chronic kidney stones to increase in fruits and vegetables. There it was. Confirmation. And they were decreasing they produce alkali, decreasing the acid load of the body. Meat and cheese and eggs do the opposite. So the doctor was right. Could it be that simple? I still didn't believe it, so we went, Dale and I went, and we went to what's called plant stock. Just not far after that, we went and met each one of these guys. I heard them, met them, talked to them. I read all their books, and I came out of there so excited. I mean, I was pumped up. Long story short, ever since then, I haven't had a kidney stone. You can come and slap me on the back. The chronicness is gone. I'm going to talk about, if I have enough time before we finish, about taking too many x-rays. I haven't gone back and taken a CT scan, and I'll tell you why, if I can get to it today. But the marvelous thing is I went there to get rid of the kidney stones. But my flank pain is gone. All those chronic metabolic conditions are now gone as well. And my weight is normalized completely. All those other things I wouldn't expect it was the icing on the cake. So everything y'all have heard before and what Clapper said, I'm a living proof of that. I don't know if I'd be here today had that not happened to, had I not gone through the pain, because it was just the iceberg, right? The tip of the iceberg for me, the canary in the coal mine. That was it was just screaming at me. There's more. It wasn't just my kidneys. It was my whole body. And of course, I'm preaching to the choir. You all know all about that. Let's talk about teeth now, finally in the mouth. What are teeth designed to eat? It's a simple question. Is there something about the anatomy of those teeth that give us a hint? What is the purpose of saliva? I mean, we see saliva, we kind of take it for granted. What are we supposed to do? Should we have a lot of saliva? Or we talk about dry mouth all the time. How about the oral microbiome? The GI guys get a lot more press with their gut and their microbiome, their biome, but we're not far behind. There's a lot of things happening in the mouth with the bacteria and viruses, the whole environment, and it's very, very important. I hope I can explain it thoroughly. And we're going to talk a little bit about fluoride and the things, the pluses and minuses of it. Now, it doesn't take a dentist to take this disc and move it and place it closest to the mammal that we're most like. All right, that's a horse, that's a bear, and that's, of course, a tiger. You think we're in the right spot? I think so. Kind of just, it looks very, very similar. It's amazing. All right, so let's flip these over, and we're going to put the skull on its back, and on this side is a deer, on that side the dog. Now let's look at this carnivore, how narrow the teeth are, and look at the width on the other side of how wide the premolars and the molars are on a deer. Now let's look at us. This is a human. What do we look like? We look very similar to this, a little bit of difference in shape, but we have a lot of width to be doing a lot of side-to-side motions, not just cutting motions. So it's an open and shut case. I used to spend a lot of time, but this is the one that just explains it quickly. What a carnivore does, it's like scissors. It cuts the food, and then it swallows it down. In Spanish, there's a word called tragar. And tragar means you're going to just swallow it. My grandma used to get mad at me. Tragas como un perro. You eat like a dog. Slow down. And I'm going to prove she was right. because we are supposed to slow down. We're all supposed to take our time. We're supposed to let the saliva work, not eat like a dog. I was always in a hurry to get up and go, and I learned from her. So let's talk about saliva now real quick. Anecdotally, my own, Dale, and my experience, within 1 month of changing our diet, all of a sudden I noticed that I was spitting on myself when I opened my mouth to eat. I was spraying myself. Now, I'm an orthodontist. I should wear a raincoat because all the kids, when they come in, they open their mouth, they spray me all the time. All right, that's why we definitely got to wear coats. They have very active salivary glands. As I got older, I don't ever remember spraying myself, but I just did it the other day, and I told Dale, I'm glad I did this again because I felt it. And I just open, and I can feel the saliva hit my wrist. The kids do that all the time. All of a sudden, I'm having more saliva. That's a benefit. And you'll see why it's such a big benefit. Anyway, I'll prove it if you look at this article comparing some salivary variables between vegetarians and omnivores. The vegetarians had a significantly higher secretion rate than the omnivore group. Now, why would that be? Is there something about fruits and vegetables? Well, fruits and vegetables are 90% water. Meats are 50%, and bread is about 35%. So I was having meat and bread, and all of a sudden I switched to fruits and vegetables. So do we need to drink a lot more? Well, I didn't drink water per se. I had a lot of Diet Coke. Now, there is water in Diet Coke, but there's also caffeine. So whatever you get, it's a diuretic, and it's gone. Your body can't use it. But fruits and vegetables, they hang around a lot. And there's some animals that they'll say, they don't even go to the water. And we had some deer on our ranch that we would hardly ever see them at the water. We wouldn't even take pictures. All the plants that they're eating are full of water. On good years, when it rains a lot and the leaves are real juicy, they know when to come in and drink water. You know, it seems like we think we have to drink a lot of water. Well, your body will probably pretty much tell you, but if you're doing this, you're getting a lot of water just from what you're eating. Let's talk about dry mouth. What are the causes of dry mouth? Well, of course, dehydration. I think I was dehydrated. I really, really was. I was dehydrated. And there's, of course, medications, antihistamines. The other thing that was cured, I forgot to mention, was seasonal allergies. I was just, this time of year especially, for some reason, I was worse in the fall than I was in the spring, back in McAllen where I lived. And I was just stuck on antihistamines. I had to have them, I had to breathe. It was just uncomfortable. I switched to this diet. I haven't had them anymore. I hope somebody could explain that to me, but that is gone. That is completely gone. High blood pressure medication, antidepressants, all kinds of medications. As we age, that's an excuse. Well, I'm aged, and I don't have that problem anymore. And I think it's because as I've aged, now 10 years hence, I'm eating the right kind of foods and staying with that diet, and my salivary flow is very, very good. Of course, tobacco and alcohol, autoimmune diseases, like Sjogren's is the attack of the body on the parotid gland, which stops the salivary flow. The results are difficulty in swallowing, taste that we'll talk about, dental caries if it's dry in the mouth, and if you got the wrong plaque in your mouth, you're going to have rampant decay. I was a general dentist first. I saw several people, elderly, that would come in with dry mouth, and we're just drilling all day long on those people. Fungal overgrowths as well. This is just to show that a carnivore, their saliva is acidic. Herbivore, your basic cow, it's very alkaline, and it's got alpha amylase, which helps in the digestion or the initiation of digestion of starches and also complex carbohydrates, of which we also have the same thing. And I don't recommend anybody doing that. I see a lot of people kissing their dogs, and that's just a lot of acid coming at you. Now let's compare a dog to the salivary glands of a human. The dog has a parotid and a submandibular salivary gland, which is down here, little one here and a little one there, and it produces saliva basically to keep them cool. So their saliva is produced and they pant, and the water's produced. It's a great system for them. It's awesome. Now they do smell, and so some more will be produced if they smell and they sense they're going to eat, just to make it a little bit slipperier, but it's not what we have. Look at the salivary glands we have. They're all over there. This is the parotid gland. If you ever had mumps, that's an old disease. Maybe some of the young ones never even heard of that. We all had mumps growing up, and that's an infection of that gland right there, the parotid gland. We have submandibular glands. We got ones under here. We got all along. There's ducts. It's a car wash, ready to go. I happened to grab these. I was putting braces on the other day. We have minor salivary glands. I was putting these braces on. They hadn't been on there for, this cheek retractor hadn't been on there for about a minute. And look at the bubbles of water. There's just saliva coming out of the lip. Minor salivary glands. If you happen to nick one of those, you can create what's called a mucocele. And being orthodontist, that happens to us a lot. People get hit in the mouth on a ball, and they didn't have a mouth protector, and then the brace itself will cut the duct that's allowing the excretion of the saliva. And now it's not communicating to the mouth, and it goes into the lip and gets caught right here. So that's saliva. That's right there. You got to go to a surgeon. They got to open that up, and they got to take the salivary gland out. Go like this to your lip, right across there. You feel all those little bumps? Those are all salivary glands. They're up on the upper lip, on the inside of your cheek, and in your soft palate. They're everywhere. So let's start with the composition and the purpose. It maintains an oral, moist oral environment. And this is kind of, you can see how watery that is. And it just creates the environment to slide things down that tube. Now, as a baby, you see, a lot of times you'll see what's called thick, ropey saliva. The younger you are, the more you're going to have that. And it's a great, great plan when you think about it. That child doesn't have all the teeth you and I have. But it still it's starting to sample some of the foods that we eat. Well, there's not enough teeth to break it down, so it'd be nice to envelop it a little more comfortably. So they got this big gelatinous mass of saliva that they swallow. What a design it is, huh? So that they can take that food and go ahead and go in there. It's very rare for an adult to have saliva like that, but we see it in kids. I mean, I'm trying to, it's like spaghetti sometimes. So how much are we supposed to produce? This is an important slide. They say, we're supposed to produce between 6 and 8 cups a day. Now, for y'all that go to Starbucks, a grande is 2 cups. So do the math. If 1 cup is 8 ounces, and there's 8 cups, if you're really good, if you're eating the way we're all supposed to be eating, we're at 64 ounces of saliva that is produced every day. Now, that's a Vitamix, guys. Y'all ever do that, the full Vitamix? That's 64 ounces. Do you have to drink 64 ounces of water? Well, I already said most of the fruits and vegetables have it, right? So you don't have to drink 64 ounces. But you do need to drink a lot more than, I surely had to drink a lot more than what I was drinking. And that hopefully is visual for you. Let's get down to the nitty gritty, a very important slide. This is the tongue, and these are the different taste buds that are on this tongue. Some of them are toward the front of the tongue, and then some are on the side of the tongue, and some of the circumvallate are in the middle. Let's take this a little closer because it's very, very important. Now, how many of y'all have ever stuck your tongue out to taste something just a little bit? You grab a little taste of that. Well, that's this salivary gland right here, this little guy right here. The very front of our tongue, the taste bud, which is this big guy on the left, there's a taste pore, is at the very surface of the tongue. So it doesn't take a lot for it to get to the necessary information. Now this taste bud has got all kinds of cells in it. It's amazing. The more I read about that, the more I'm just amazed. Some of those go to our brain, some of it go to our stomach, some of them are going to the immune. Everything, information that's coming in our body that comes from just a simple taste of where the information is processed in our body in order to do something that's coming up next. Are we going to swallow that? Or are we going to spit it out? Now, usually when you're tasting it, you want to know if you want to continue eating that, something that's going to taste good or not. But sometimes you do taste it, and it goes into the next level. So we're over here now. It's coming in, you taste it, you swallowed it. Now it goes in what I call the fjords of the tongue. It's got to go down here because the taste buds, can you see that? That bud is on the down in the crevice of that tongue. So if you're dry mouth, it never gets in there. So I'm wondering, when I was young and I was very, very picky eater, and I was just tragando my food, whether they ever got in there, and I was picky because my body didn't ever have a chance to develop to recognize that food and to do the things that I'm going to show you that the body does to make it more palatable for us to have it. Now, further back down the road, the circumvallate, which is way back here, and y'all been told, scrub the back of your tongue. Have y'all been told that? Well, I'm going to tell you not to do that. If you're eating the right foods, the right bacteria is back there. It's the one that should be there. It's the one that needs to take the information from these little buds. It's got to get in here, and it's got to evaluate what you just ate. And it's going to process it, and look what happens. Let's talk about it next. So one of the first things are voluntary. So we decide, we put it in the mouth, and we process it, and our brain and our memory processes it, and you can voluntarily turn around and spit it out. I can remember the first time I had caviar, and I didn't know what it was. And I put the whole thing in my mouth. And I was looking to do that somewhere. The first time I was looking for somewhere, and it was unfortunately at a party, and I had to get out of the way quickly because I did that. I don't know if you've ever taken, just to give you kind of an idea, a similarity, an analogy. Anybody that's ever taken the first puff of a cigarette, what did you do? Coughed. Isn't it amazing how our body senses something? This is the same analogy, except the coughing was probably involuntary. It got down too far, and the body wanted to get rid of it. The body was telling us right off the bat we shouldn't have that. Now, as we get further back, there's going to be some involuntary motions. If that goes down, and the messages come from that taste bud, and it goes further down and senses that we need to initiate something to get rid of it permanently, and it's not voluntary anymore. You can't do it. Sometimes you wish you could, and it's gone. Has anybody ever had that sensation where I know I'm going to throw up? You ever had that? You know it's preparing you. Get over to the bathroom right now. It's telling you, get your legs and go, because it's going to involuntarily get rid of that. And that's all things that have started with the saliva diluting that information, getting it into those pores, and sending it to all the centers that need to know. It's an amazing body that we have. One of my favorite slides. Anybody do this to a little kid? They want them to taste that lemon because you just can't wait to take a picture of that. But let's see, what is that child doing? It's an involuntary response because there are buffering compounds that are present in the saliva that it senses the salivary glands is already telling that child, I need to produce more saliva. So I'm going to grimace and I'm going to work on the muscles that are around those salivary glands, and I'm going to make them dump it out quicker, okay? Quickly dump it out so that I can minimize that reaction or minimize that taste. And it also does it for sweet, for bitter, and salty. It does it for all of that. It's an amazing body that we have. Have you ever had a lemon and you sensed it happen? It's kind of a real weird sensation. That's the fibers that are pumping it. They're pumping it, getting it out. It's an amazing, amazing body we have. Just to be complete, this is not the mouth, but you can smell things and your salivary glands can produce. You can even see them. You can see it at a distance, and all of a sudden you sense the salivary flow. Of course, the biggest purpose is to envelop it, to take your time. My grandma was right. Chew your food. Spend time. Enjoy it. Let the body understand what it has. And you also don't want to abrade the body. Have you ever got a hold and started chewing something and noticed, there's something in the food, right? So it gives you time to grab it and take it out. Or if you do it too quick and that goes further south, and then you start to abrade things, and so if you didn't take the time, the way it is built for us to take time to chew, that's what our teeth are made for, take time and chew it. real important slide. It's called demineralization and remineralization. Very, very important, and I hope I explained this correctly. There's probably not a more important slide than this one. After eating high levels of acidity, okay, like if you had a lot of citrus food, something like that, if you're squeezing a lot of lemon on your food that you have, which we like to do, if you had a lot of acidity, so what the body does, it leaches calcium to buffer it, to create a neutral environment. Remember what the hospitalist told me, your body wants to be 7.0, and it's going to do everything it can. So the teeth are full of calcium. So is what else? Our bones or our foods. So it's going to get it from somewhere. It's going to do its best. Well, the best source, if there's a lot of acidity in the mouth, is the body will neutralize it. It'll take some of the tooth to do it. But I'm talking microscopically. I'm not taking chunks. The problem is, what else can get stuck to the tooth? Plaque. And if it's the type of plaque that's the wrong plaque, which I'll explain in a second, then it continues to leach it and leach it and leach it. The plaque doesn't eat the tooth. The tooth dissolves itself to neutralize the acid. That's when the hole comes in, then you get a cavity. And as an orthodontist, I'm really concerned about it because if it's all around the bracket, we don't want to take the brackets off and all of a sudden we got all these ghost-looking things around your teeth where the calcium has leached off the tooth. It's horrible. So this is a real important slide to show that the body, that happens naturally. So the saliva wraps around that food, it wipes against the tooth, and then the tooth, the acidity of it leaches the calcium out to neutralize it. Okay, so let's say you eat it. Now another source is coffee, dark tea, hibiscus tea. Those are all three very acidic liquids. So when they get washed over that tooth neutralizes it. So calcium comes off. I'm talking microscopically. But when you stop eating and you go into the rest mode, the saliva have already sent that message into those pores to the higher centers that come back and have started to leach calcium and phosphorus from the rest of the body. And while you're resting and you stop chewing, the saliva is higher concentrated in calcium and phosphorus. Amazing. So whatever came off automatically comes back in. It automatically does. So it's neutral. What a design, huh? Whatever came out, you stop eating and you're quiet, let the saliva flow, and it covers it. No problem. The problem is if you're gum chewing in between. And I'm a proponent to tell you it's probably not a good thing. The body needs to rest. If you're gum chewing and it's going this and this and this, the body doesn't know that's gum, just like it didn't recognize processed food. It doesn't know it's gum. All I know is that something's chewing, and I got to keep pumping the old saliva out. I don't have time to remineralize because I got to get saliva in there because there's more food in there. So I would recommend don't gum chew. Let the body rest, and it recalcifies itself. An amazing system. You're going to see something that fluoride is going to say that it does all of this. In just a second, it doesn't. We don't need it because we do it on our own right there. Anyway, there's bacterial properties that we have. Also antibacterial, antivirus, antifungal, all of those things happen in the saliva itself. A little bit about microbiome, just real quickly. What I'm going to touch on is that the biome of the mouth is amazing. And I'm going to talk about the progression of disease toward disease or health of the mouth. And there's one, I need to talk to you about this. This slide was done from skeletons from 3,000 years ago to present day. And this is the important slide that I'm going to say. So I don't know if there wasn't any dentists 3,000 years ago. But what this shows is that the cavities for 100 teeth from the year 3000 BC till 1850 was 5 to 7 was the average cavities per 100 teeth. When we hit the 1850s, which is right here, it went to 25%. So 25% of our teeth are decayed in modern day because of something that happened in 1850 and toward this way. But before, without any dentists, we didn't have any cavities. And that's coming off of these skulls right here. So here's a caveman type of skull, and there is tartar right there that can get analyzed. And let me just show you again from a different perspective. These are not cavities. These teeth are wearing down as they age. Now they will break them, and when there is a break in this tooth, like you see the breaks, then there's small cavities that do occur there. But of all the skulls that were examined, there was no infected teeth. There was no abscesses. There were minor decays. So a spectrophotometer is a way to get a color fingerprint of anything. So Dr. Alder did an amazing study that he compared the skulls to the bacteria of skulls from 3,000 years ago, just like what you saw, to modern day. And what I want to just say about this graph is you can see up until 1850, no matter what food that we ate, the bacteria of those skulls was the same. The microbiota, the microflora of cavemen were all the way to 1850 was the same. Even though you farming, you did all this stuff, the plant foods, wherever they ate, the bacteria didn't change. It was very diverse. What happened was in 1850, when we had the second biggest change, instead of just farming, we went to processing our food, and all of a sudden the bacteria changed in the mouth. And it went from a very nice bacteria for us, very low disease making, no gum disease, to one where the red part, you see the red cable, the red stripes there, color? Those are full of bacteria since 1850 that cause dental decay and cause dental gum disease. So that's what happened. So when we changed the foods to process it, all before those bacteria were in our mouth, but they're in very small quantities. We changed the food just like you change the food in your gut, and all of a sudden the bad bugs grew. Now we got dental disease. Fluoride, we're talking about advertisements and marketing. They'll always say, well, we can refluoridate a tooth, we can remineralize a tooth, we can do all of these things. But don't forget this slide that I showed you, but we do it naturally. So you really don't need the fluoride if you're eating the foods that you should be eating, and most everybody, I would hope everybody is here. So when you go get your teeth cleaned, which I think you should do, they're going to ask you, do you want fluoride? They're going to charge you for it. When they ask you that, tell them, no, I don't need it. I don't need the fluoride. And just to show you the reason why is fluoride, fluoride says it improves the cavity rate by 50%. Well, it improves 75% if you just get on the right foods. So it even beats fluoride. It's not equal to it, it's better than fluoride. And there's some problems with fluoride. I will just say that today, fluoride is everywhere. I was part of the community dentistry group, and we went in San Antonio in the 70s, and we beat on their desks and said, we need fluoride in the water. Back then, there was no fluoride anywhere. The problem is we were successful. Now, everybody's got fluoride. So everything you see, not just in toothpaste or oral hygiene products, it's in processed food. Everywhere that they process water into something, it's got fluoride in it. So there's no reason to use it. It's too much. Okay, I think I'll stop. All right. Thank you very much.